Welcome everyone. I'm excited to kick off today's presentation on data schema, database management, and platform security. Today, we'll explore how these elements work together to create a robust and secure data environment. Over the next few slides, we'll cover key concepts, best practices, and some real-world examples. Let's get started. Let's talk about data schema. It's essentially a blueprint that defines the structure of data. Think of it as a map that organizes relationships between different pieces of information. This organization is crucial because it helps us store and manage records efficiently. By having a clear schema, we can maintain data consistency, which is vital for accurate and reliable information. In the context of application design, the data schema is the foundation. It guides how the system is built and how different components interact. Specifically, in ServiceNow, understanding the data schema is key to how the platform functions smoothly. So, in summary, the data schema isn't just about data storage. It's about creating a structured, reliable environment that supports the platform's overall effectiveness. All right, let's talk about tables in ServiceNow. Think of a table as a collection of records, similar to what you see in Excel with rows and columns. Each table stores a specific type of data, such as incidents, users, or tasks. These are the core building blocks of the system. Some tables are standard, meaning they come with ServiceNow, while others can be custom-built to fit specific needs. Every table has a unique name, which helps us identify and work with it easily. Understanding these tables is fundamental because they organize and structure all the information we work with in ServiceNow. Now, let's talk about data at the core of our database. Data is organized into individual stores, which are like containers holding specific pieces of information. Each store consists of fields, and these fields are like columns in a table. They hold different types of data, such as names, numbers, or dates. It's important to note that each field has a data type, which helps define what kind of information it can store. Some fields are mandatory, meaning they must have a value, while others are optional. These details are defined in a dictionary, which serves as a blueprint for our data structure. Finally, fields control how data input is handled, ensuring consistency and accuracy as we work with our data. Overall, understanding how fields and data types work together is key to organizing and managing our information effectively. Now let's take a closer look at the different data types we encounter in our databases. First up, we have string, which contains text values. Think of names or descriptions. Next, integer refers to whole numbers like quantities or counts. Then there's Boolean, which is all about true or false responses, perfect for yes-no questions. Moving on, date time captures specific dates and times, essential for tracking events or deadlines. Choice or drop-down options give us predefined selections to keep data consistent and organized. Lastly, reference links to other tables, helping us connect related data across different parts of our database. Understanding these data types is crucial because they define how we store, interpret, and work with our information. Recognizing the right data type for each scenario ensures our data stays accurate and useful, which ties directly into our overall goal of effective data management. Now, let's take a closer look at how we manage our data through the dictionary, or what we often call metadata. This is a crucial part of our system because it helps us define the structure and behavior of our data fields. First, we have the ability to set stores field definitions, which means we can specify exactly what each field should contain. Then, controls field properties, allowing us to customize how these fields behave and appear to the user. We also set default values, so when a new record is created, it starts with sensible initial data. Managing field behavior is another key aspect. This includes things like validation rules or how users interact with the fields. Labels and types are also managed here, ensuring that each field is clearly identified and has the appropriate data type, like text, number, date, and so on. All of these configurations are handled through a back-end configuration tool, which provides a centralized way to control and maintain our data structure efficiently. In essence, this slide highlights how vital it is to have a well-organized metadata dictionary, as it underpins the integrity and usability of our entire system. It connects to our overall theme by showing how structured data management is foundational to building reliable and user-friendly applications. Now, let's look at how relationships connect different tables within a database. When we talk about a one-to-many relationship, it means that a single record in one table can be linked to multiple records in another. For example, a customer can place many orders, so the customer table links to the orders table. On the other hand, many-to-many relationships are a bit more complex. They occur when multiple records in one table relate to multiple records in another, like students and courses. To manage this, we often use reference fields, which are essentially foreign keys that help maintain these connections efficiently. By establishing these relationships, we keep our data linked properly, which makes retrieval and updates much easier. It also enhances data organization, reducing redundancy and ensuring consistency across our database. Overall, understanding and implementing these relationships is crucial for creating a robust, efficient database structure that supports our data management needs effectively. Now, let's talk about how links work between tables. Essentially, a link connects one table to another by storing the SysID of a record. For example, if you have an assigned to field, it would store the SysID of a user. This approach ensures that the data remains accurate because it always points to the correct record. It also helps prevent duplicate data since you're referencing existing records instead of creating new ones. These reference fields are particularly useful in forms, making data entry more consistent and reliable. Overall, they play a vital role in maintaining data integrity across the system. Now, let's take a closer look at the visual representation of tables. This is really about illustrating the relationships between different tables within our database. By doing this, it becomes much easier to grasp the overall structure and how the pieces fit together. This kind of visual is especially useful for developers who need to understand data flow and dependencies quickly. It also displays reference connections, showing how tables are linked through keys and relationships, which is crucial for ensuring data integrity. And of course, having this map helps improve troubleshooting because you can easily pinpoint where issues might be originating within the database structure. Overall, this schema map is a powerful tool. It helps us visualize complex relationships clearly, supports efficient development, and makes maintaining the database much smoother. It's all about making the structure more accessible and understandable, which ultimately keeps our system running smoothly. Let's talk about creating child tables from a parent table. This approach allows you to inherit parent fields, which helps reduce duplication and keeps your data structure cleaner. For example, if you have a task table, you can create an incident table that inherits from it, reusing common fields while adding specific ones. This setup supports a hierarchy, making your data more organized and easier to manage. It also allows for easy customization. You can extend the parent table without altering the original, which is really useful for maintaining flexibility as your system evolves. This concept of table extension is powerful because it promotes reuse and simplifies updates across related tables, aligning well with our overall goal of efficient and scalable data modeling. Now let's take a closer look at the incident table. Here, you'll see several key columns that help us understand and manage each incident effectively. First, there's the incident table number, which is simply a unique identifier for each incident, making it easy to track and reference. Next, we have the caller, which points to the user who reported the issue, so we know who to follow up with if needed. The state column indicates the current status of the incident, giving us a quick snapshot of where things stand. Then, there's the created date, showing exactly when the incident was logged. To make this clearer, I've included a real example on the slide. This table structure is fundamental because it organizes incident data systematically, ensuring nothing slips through the cracks. It also connects to our overall goal of improving incident response and resolution times by providing clear, accessible information. So, understanding this table is crucial for effective incident management and ultimately delivering better service. Let's wrap up with some key takeaways. When it comes to reporting and scalability, it's crucial to remember that well-designed data schemas are the backbone of ServiceNow. They enable better performance and more effective reporting. Essentially, a good data schema sets the foundation for scalable and reliable service delivery. By focusing on designing robust schemas, we ensure that our systems can grow and adapt without sacrificing speed or accuracy. In conclusion, the way we structure our data directly impacts the overall success and efficiency of our ServiceNow solutions.